Hello YouTube and welcome to Heathen Hacks. Today we're going to talk about the basics of RSYNC. What it is, why do we use it, how do we use it, and do some basic tests to demonstrate how awesome it is. Let's go! What exactly is RSYNC?
I'm glad you asked that.
RSYNC, or its GUI version, RSYNC, is a differential backup and file synchronization tool or utility that is widely used and found on Unix-like operating systems like Linux and macOS. Apparently, it has also been ported to Windows via Cygwin and the now discontinued SFU or Windows Services for Unix, but that's not the focus of this video. Its most basic use case is for syncing your directory to another location, like to another drive, to a cloud storage, your NAS, or to your dedicated home server, and as a byproduct, also back up your stuff in the process. RSYNC has the capability to do incremental backups by comparing the contents of the source and destination directories. It finds files that need to be synced using the LQ Quick Check RQ algorithm that looks for files that have changed in size or in last modified time. Any changes in the other preserved attributes as requested by options are made on the destination file directly when the quick check indicates that the file's data does not need to be updated. You can find more information about the algorithm on this PDF that you can download from CMU's website. Link down below. It was published by the authors themselves, Andrew Tridgell and Paul Macaras. As a quick example, if you have set it up to do so, it would check if there are any changes on the files inside the source directory, like if new sentences or words were added into a Word document or text file, if there are any new and additional folders or files, or if something was deleted. It would then update, replace, or delete the ones on the destination directory and replace or update them with the ones from the source if the files in the destination directory are outdated. So, if file A inside the source directory was deleted prior to the sync, and if that same file A is currently present inside the destination directory, it would also be removed or deleted from the destination directory on the next sync. Doing so would yield to less time spent on backing up or syncing your stuff because it would only update, change, delete, or copy files that were added, deleted, or changed in the source directory. You can also add it to automation scripts, cron jobs, or KDE Task Scheduler, which is really nice. Alright, first up, let's launch our file manager. I'm using Dolphin and I'm on my testing VM, by the way. For this simple demonstration, we will set up a test source directory and set up another test directory for the destination, which would be located on a different drive. I have already prepared the sample files that we're going to use, and they are in another folder inside this folder, which is shared between this VM and the host machine. This is it, and this is the main shared folder on the host. See? These are the same files inside the VM's shared folder. Inside this test files folder are commonly backed up files such as audio, documents, images, videos, and zipped files. Now for the test, let's make the source folder inside this VM's home directory. Move the contents of the files folder to it. Let's delete this. Then make the destination folder inside the shared folder. For context, this VM is installed to my Games and VMs drive, which is on my WD Black SN850X 2TB M.2 NVMe SSD. And this shared folder right here is on the host machine's home directory that is on my Linux drive, which is on my WD Black SN750 500GB M.2 NVMe SSD. TLDR, they are on different drives. After setting up our source and destination directories, let's see if RSYNC is installed, and of course, install it if it's not. And to do that, since I'm on an Arch derivative distro, I'm going to use Pacman. Specifically, Pacman Q RSYNC, where Q means query. Well, it's not installed yet, so let's install it. Pacman S RSYNC, where S means sync or synchronize packages, where packages are installed directly from the remote repositories, including all dependencies required to run the packages. Now that it's installed, let's take a look at the manual by searching for RSYNC man on our preferred search engine. And there it is. The default syntax for local syncing is this. Just set up the options, add the source and destination paths, then it's good to go. Just a reminder, we would only focus on local syncing and will not include these things because they may be too advanced for beginners and for me. and I won't be using this feature anyway. To simplify the process, I have created an RSYNC template where I would only need to change the source and destination paths every time I want to set one up, and here it is. In hindsight, we don't actually need a script for this since we can just enter the commands manually, but because we humans tend to forget stuff,
From the moment
I think it would be better to make one and then execute it whenever needed. If we take a look here, this is the source directory and this is the destination. Here are the paths: home, arcoheathen, src, and home, arcoheathen, dest. If we copy this and just run it using the terminal, RSYNC would still work even without using a script. See? It still did its thing. Now, to understand how it works, let's take a look at what each option and the syntax does together with some demonstrations while we're at it. Speaking of options, here are the options: R, T, P, G, V, delete, L, I, S, and update. We'll go through each one of this later, but first, let's start with a sort of blank script where the source and destination directories are the only ones included. I think this would be a good way to demonstrate what each option does. Doing it this way could also show what combinations work and what doesn't, allowing us to troubleshoot it and learn more along the way. Okay, just gonna go cut these things, paste them here, then let's add a comment here. Let's delete these files first. Go back to the terminal, enter clear. Let's see what would happen if we run the script without any options. Let's copy the file name, then enter period, / and press Ctrl+Shift+V to paste. And since we opened the terminal inside the source directory, we can get by just using the script without including the path. And, as expected, it did nothing. But since the purpose of this script is for us to basically clone our chosen directory to another drive as a backup for when an update causes things to behave strangely, or if we messed up some settings and or have deleted some files accidentally, we would need to use the R or recursive option. This tells RSYNC to copy everything including subdirectories. If you just want something simple without all the bells and whistles, you can just use this option, followed by the source and destination directories, and call it a day. Alright, let's edit the script, cut this, paste this R here, then save our script. What this will do is copy all of these, including the subdirectories, to the destination. In this case, src folder is the parent directory and all the folders inside it are the subdirectories. Also, in order to not confuse ourselves, in this context, the terms folders and directories are basically the same and interchangeable. Inside subdirectories, we can have some files, and on this example, we can also have a subdirectory inside a subdirectory inside a subdirectory inside a subdirectory inside a subdirectory. Again, this tells RSYNC to copy everything including subdirectories. Alright, let's run the script. rsync template.sh. There it is. It copied everything, including all the subdirectory inside the subdirectory inside the subdirectory inside the subdirectory inside the subdirectory. Before we forget, to showcase the importance of it, let's see what would happen if the recursive option is not included. So let's remove the R option and place it right here. Then add these options to the main script to make it a complete script without the recursive option included. Save it, then run our scripts. But let's delete all these first. Alright, let's run the script, and delete does not work without recursive option. Well, let's move the delete option here, save the script, and run it again. And still, nothing happened, because without including the R or recursive option, even if we have a fully loaded script with a lot of options included, like this one, nothing would be copied to the destination because RSYNC just doesn't work like that, I think. Basically, without the recursive option, the contents of the parent directory are invisible to RSYNC. Or are they? No, I don't know. Quite similar to when you try to copy a folder to another folder using the terminal, it's not possible without including the R or recursive option as well. Using RSYNC without using the recursive option is not entirely impossible, but you'd need to specify the file names including their file extensions when doing so. Let's say we want to copy this image, this PDF, and this folder. Well, I think we can't copy folders, but let's just try anyway. Okay, click on save, clear, then run the script. See, even if we have included the audio folder to the specified items, it was not copied to the destination because it is a subfolder, and we did not include the recursive option which is needed to transfer subfolders. Now that we have finished showcasing the importance of the recursive option, let's restore our script back to its former state by transferring all these options back to their previous locations, then add the recursive option as our only one. Click on save, clear, and run our script again. As you can see here, after running the script, it just finished without providing us any details. Well, that's because RSYNC works silently by default. So if we want to see some more details about what files are being transferred and a brief summary at the end, which would be useful for monitoring its progress and for making sure that the synchronization is going as intended, we could add the V or verbose option. This tells RSYNC to increase the amount of information we are given during the transfer. Okay, let's delete all these, edit our script, cut V, paste it here, save. Then let's run RSYNC again with the updated script. And there we have it. Here are all the files and folders that it copied from the source directory. And the brief summary at the end containing the total amount of data that was sent by the source, followed by the total amount of data that was sent by the destination, the overall size of the files, and the speed of the transfer. Now, as you may have noticed, the received data seem to be too small compared to the sent. That's because the destination only sends checksums and block indexes to be compared to the source. And since the destination is essentially empty, it sent a really bite-sized size. But of course, when backing things up to have better organization, in general, we want our files and folders to have the correct timestamp metadata and or creation date and last modified or edited dates to be the same on both the source and destination directories. However, if we take a look at the modified time of the files inside our source and destination directories, they're really different because by default, RSYNC uses the current time and date when copying files. In the source directory, the majority of the files and directories have February 22, 2024 as the modified date, but on the destination directory, they are all April 13, 2024, 12:55 p.m. See? The same file, different time. This is the current time and date, April 13, 2024, 12:57. So to make sure that the time information is preserved during the transfer, we have to include the T, this one, or times option. This keeps track of when the files were first created and when they were last changed. Let's include the T option right here and save our script. Let's delete all these files. Take note that the modified time on this is the current date and time. Go back to the terminal, enter clear to make it more clean, then run the updated script. See that? The modified time of the files inside the destination folder are now the same with the files inside the source folder. Dealing with file permissions like who can access, edit, or delete our files can be a hassle sometimes. So, to ensure that our backups would behave exactly like the originals, including who can access and modify them, we can add the P or perms option. This option tells RSYNC to preserve all the permissions on the files and folders that are being copied. This way, our backups will inherit the same access controls as the ones on the source directory. For example, let's take a look at the permissions of this image. Right-click, Properties, Permissions. As we can see, the owner and group can both view and modify it. Advanced permissions contain the same info, by the way. R is read, W is write, and X is execute. Now let's see what would happen if we run the script without the perms option. Let's open the terminal here. Let's run the script. There we go. Let's take a look at the perms again to compare. Right-click, Properties, Permissions. So, on the image that is in the source directory, we can see that both the owner and group can view and modify it. But on the same image that is in the destination directory, the group can only view. Clicking on the advanced permissions, we can also see the same thing. We can also check for file permissions, these things, using the terminal by copying the file location together with its file name. Let's say this one. Right-click, copy location, then using our terminal, enter ls, small l followed by s or list, followed by dash, and small l or use a long listing format because by default, ls would only list the file name and extension. Let's paste the file name and extension here, and here it is, rw r blank. If we take a look at the advanced permissions, we can also see rw r blank. Let's do the same thing on the file inside the source directory. Copy, lsl, Ctrl-Shift-V. See the difference? This is RW and this one is just R. And as mentioned before, without including -L, this would only show the file. Alright, let's clean this up, delete all these. Then let's update the script by adding the P or perms option. Cut, paste, save, clear, then run the script again. Okay, let's check the source file's properties. Permissions, owner and group can view and modify. Advanced permissions shows RW. Now let's check the destination file's properties. Permissions, owner and group has the same permission as the source, and advanced permissions also show the same permissions as the source file. See? Quite similar to the perms option, this next one also deals with permissions, but this time it's for user groups for better compartmentalization. There are certain instances where user groups are necessary to be set up on our system even if we're the only ones using it, such as but not limited to virtual machines like VirtualBox, where we need to be a part of the VBox users group to be able to share a folder between the host and the VM properly. Adding the G or group option tells RSYNC to set the group of the destination file to be the same as the source file, while the group is set to the default group of the invoking user on the receiving side when it's not included. For demonstration purposes, let's take a look at some random files and check what group they belong to. This image belongs to the VBox SF group or this VM. PDF belongs to VBox SF group as well, same with this audio and this zip file. This is our current script. Let's run it without the group option included. There we go. Let's take a look at the same files in the destination. As we've seen earlier, this image belongs to the VBox SF group, but the same file inside the destination folder belongs to our Heathen or the user group. Just like what was mentioned earlier, the group is set to the default group of the invoking user on the receiving side when it is not included. To double check who the user is, we can enter "Who am I" on the terminal. See? So, Heathen is the default group of the destination directory and VBox SF is where the source directory belongs to. These other files also belong to the Heathen group now. Let's delete these files, clear the terminal, update our script. Let's add the G option, cut, paste, save, then let's run the script again. After running the script again, these files should also belong to the VBox SF group even in the destination directory. Okay? VBox SF, VBox SF, VBox SF, and this one is VBox SF. There we have it. It works like that. Now let's clear the terminal again, then delete these files. It seems like I forgot to add it to the script, but we also have the progress option that we can add to accompany the V or verbose option to have an even clearer picture of what's happening during synchronization. To illustrate the difference, let's run the script with and without the progress option, saving the output to files named progress N and progress Y respectively. We can then use a diff tool like meld to compare the results after. I have a duplicate of the script outside the source directory. This is the one I'm using at the moment to save the output text files outside the source directory. Let's open the terminal inside the home folder. As you can see, this tilde right here is the symbol for the home directory. Let's run the script with the greater than symbol to generate a text file that contains the output and name it progress N to indicate that the progress option was not used. Well then, let's run the script. As visible right here, the script still performed its task and synchronized the source directory to the destination. It only looks like the script did not do anything because there was no output. But, as you can see, a progress and text file was generated outside the source directory where the duplicate script is located. And if we open it, we can see what the terminal was supposed to output. Okay, let's delete these files again, update our script to include the progress option, then let's run the script again. But replace progress N with progress Y to state that the progress option is included this time. Run the script. There's the progress Y text file that was generated. Check if it has an output. Then let's compare the two files using meld. Evidently enough, the inclusion of the progress option provided additional details. I mean, just take a look at how long this is. Let's take this video file as an example. 2023-11-16, here we have the file that is currently being transferred. This represents the initial transferred chunk of data, which is 32768 bytes, because RSYNC often starts by sending an initial chunk of data as a handshake or verification step for initial connection and basic file information exchange before proceeding with the file synchronization. This indicates the current completion percentage. Since the transfer just started, it's 0%. This shows the current initial speed of the transfer, while this is the estimated time remaining for the transfer to complete. This is the total number of bytes transferred. When converted to MIB, it becomes 53.44 megabytes, which is the size of the file itself. As we can see here, if we take a look at the video file's property, its size is 53.4 megabytes or 56,031,796 bytes. 100% indicates that the file has been transferred completely. This represents the current burst of speed due to current network conditions and may fluctuate from time to time. This is the remaining time, which is 0 because the transfer is complete. XFR number 3 indicates the current transfer number. As we can see in the source directory, it's the third file out of all the files, not including subdirectories. This tells us which file out of the total RSYNC is currently working on. If we go back to meld, XFR number 1 is this image file. Second file is XFR number 2 or this PDF. Going back to the source directory, the image file is the first file when not including the subdirectories. Second file is the PDF, and third one is the video file or XFR number 3. It's basically the transfer order of the files. So, RSYNC starts with the very first file inside the source directory, then moves on to the files inside each subdirectory. This part shows how many files RSYNC has left to check for transfer out of the total number of files. In this case, there's a total of 140 files left to be checked out of 145. The default progress option provides a good set of data, but just in case we find it a bit too cluttered or if we just wanted to monitor the overall progress of the whole directory instead of each file, there's a way to do it by just adding a few things to the default progress option. Alright, let's update our script. So the default progress option is just this. If we want to monitor just the overall progress, we can just add info equals n2. Click on save. Let's run our script again, and this time let's save it as progress2 to indicate the usage of progress2. There we go. If we compare the previously generated text file that uses the default progress option to progress2, we can see that they are different on quite a few aspects. First, let's take a look at the image file. For starters, on line 3, both options have the currently transferred file shown, which is this image, followed by the initial chunk of data, which is 32768 bytes, because RSYNC often starts by sending an initial chunk of data as a handshake or verification step for initial connection and basic file information exchange before proceeding with the file synchronization. Line 5 displays the current file transfer completion percentage, which is 3% on the default, and the overall total transfer completion percentage on progress2, which is 0%, because the synchronization just started and progress2 also takes into account all the files inside the source directory. The current transfer rate and elapsed time are both zeros because again, the synchronization just started. On line 6, the default progress option shows the file size, which is 987615 bytes, same with progress2. 100% current file transfer percentage on the default because that certain file just finished synchronizing, while progress2 states that the overall transfer completion percentage is at 0% because it takes into account all the files inside the source directory. As you can see, if we move further down the line, the overall transfer completion percentage changes from 0% to 1% to 5% and so on. We can also see that on progress2, instead of listing the size of each file, it adds them up incrementally. So 987,615 bytes is the size of this image file, and 12,015,546 bytes is the size of this PDF, which when added becomes 13,003,161 bytes. And just like the default option, progress2 also provides the estimated transfer speed, the estimated elapsed time of the transfer, what file is being transferred provided by the XFR number, and the information about how many files RSYNC has left to check. Right, I'm not sure why I've only thought of tiling the windows like this now, but let's proceed anyway. Here we have the delete option. This tells RSYNC to delete the files and folders in the destination directory if they are not present in the source. This option ensures that the destination directory is an exact copy of the source. To test, first let's delete some files inside the source directory. Then, as usual, run the script with and without the delete option included to see the difference. So here are the current files and folders present in the destination. Let's just take a mental screenshot of it. Now let's delete some files inside the source folder. Let's say these 3 right here.
Delete.
Then let's run the script. As you can see, the files that were deleted from the source were not deleted from the destination. Let's update our script to include the delete option. Save our script, then run it again. And there we have it. The destination directory have also deleted the deleted files from the source. In addition, we have the lowercase l or links option. This tells RSYNC to recreate the symlink in the destination if they are found in the source. Symlinks or symbolic links are sort of shortcuts to files and directories located on other locations. Let's say we have set our home directory to only have 10 GB of storage. For ease of access, we want our entire music library that is located on another another drive with a larger capacity like this one, which is stored on a 1TB drive to be present inside our home directory's music folder. The problem is our entire music library is about 58.1 GB or 62.3844 GB in size. Alright, let's copy the location of this, then make a symlink. This is where symbolic links would extremely be useful. It would give us a doorway or a shortcut to our entire music library without having the files themselves stored on our home directory. As you see here, it's the same thing. And if we ever delete the shortcut, nothing would happen to the main directory due to the deleted symlink only being a shortcut. For this test, let's add some symlinked folders or directories inside the source. Let's say this downloads folder, pictures, and this shared folder. Just to reiterate, we've only made a few symlink folders of the downloads, pictures, and shared folder. Alright, let's clear the terminal first. Let's run the script without the links option included. Well, as expected, the symlink folders weren't copied to the destination. Alright, let's update the script to include the links option. Click on save, clear, run it again, and there we have it. The previously created symlink folders were also copied to the destination. We also have or ITEMIZE changes option. This makes RSYNC request a simple itemized list of the changes that are being made to each file, including attribute changes, or to show the actions RSYNC would take like copy, delete, skip for each file. For this, I have deleted most of the files inside the source directory to lessen the items that the terminal displays and for us to better focus on what's happening. Let's run the script without the option first. As expected, nothing happened. Now let's say we have changed the permission of this video by removing the executable permission. Run the script as is, again without the option. It still displayed the same thing, but if we take a look at the video file in the destination, we can see that the permission of it also changed. Now let's update our script by including the option. Let's put this right here, click on save. Let's change the permission of the same file inside the source directory again by restoring the executable permissions back. Clear the terminal, then let's run our script. There it is. We can see here that something appeared at the beginning of the file name. F stands for normal file and P stands for permission. Basically, this tells us that the file's permission has been changed or updated. Now, let's add an empty folder in the source directory and run the script again just to copy the blank folder. Let's change the folder's permission by removing the executable permission. Clear the terminal, then let's run our script again. It shows the same thing, but instead of F, it's D for directory. Now let's change this audio files group from VBoxSF to ArcoHeathen and run the script again.
One more time!
There we go. This time it shows F for normal file and G for group. Now let's delete this audio file and run the script again without the option included. There we go. The same file was indeed deleted from the destination, but the terminal did not mention any of that. Now let's add the option, click on save, let's delete this blank folder, clear the terminal, then run the script again. As you can see, compared to when the option was not included, it states that it deleted the directory. Next, we have the S or protect ARGS option. This protects special characters in arguments passed to RSYNC. It ensures that any arguments containing spaces or other special characters such as asterisks, question marks, dollar signs, and so on are properly interpreted by RSYNC. This option may not be as important when only syncing to local drives and not on remote machines though, but might as well include it because why not? Okay, let's run the script without the protect ARGS option. As you can see here, I have added another blank directory and a few sample text files with a lot of special characters included, but they were still processed properly even without the S or protect ARGS option. Now let's update the script to add the protect ARGS option. Save the script, delete these files, then run the script again. See? No difference whatsoever. And lastly, we have the update option. This forces RSYNC to skip any files which exist on the destination and have a modified time that is newer than the source file. If an existing destination file has a modification time equal to the source files, it will be skipped unless the existing destination file and source file differ in size. In order for this option to work correctly, we have to remove the delete option because they contradict each other. Because the delete option tells RSYNC to delete the files and folders in the destination directory if they are not present in the source. So let's try making a sample text file inside the destination directory. Clear the terminal, then let's run our script as is. Alright, so the added sample text file was deleted due to the delete option being present. Now let's update the script by adding the update option. Now take a look at this. This is really awesome. I just remembered that you can also drag and drop texts when using kwrite. Alright, save our script, make another sample text file, then run our script. As you can see, the sample text file was deleted even if the update option was added. So if we want the update option to work, we have to remove the delete option from our script. Alright, let's just drag the delete option down here, save the script, make another sample text file in the destination, change this text file size by adding some texts on it, clear the terminal, then let's run the script again. And there we have it. The sample text file and the edited text file remained, even if they are different from what the source directory contains. The problem with this option is that it doesn't really delete stuff. So let's say we have a sample test directory in the source that was previously synced and is now present in the destination. If we delete the sample test directory in the source and do another sync, it would not be deleted in the destination because of the delete option not being present. I guess using the update option instead of the delete option when your main goal is to have an exact copy of the source directory is not that good of an idea because, well, it keeps everything, even the already deleted source files. So I guess this would be good for version controls. I don't know though. Well, that's basically it really.
That's interesting. Things that make you go,
It may seem convoluted at first by just looking at it, but once you have explored the manual a bit and have gotten the hang of the basic options, it's quite intuitive. RSYNC is a really powerful program, not just for synchronizing files, but also for backing stuff up. If you want to try using RSYNC for the first time, I suggest making some test source and destination directories first, then populate them with random files and folders. It would be even better if you do it inside a virtual machine so that you have peace of mind that your main system won't be affected. But doing so just inside your home directory would also be just fine. Well then, what do you think about the template? Is it a good starting point? Did you even learn anything? Let me know your thoughts down below. Thanks for watching and see you again next week. Maybe.